is from Serena Chierici, from SICA, here in Italy. Serena graduated in chemistry at the University of Pavia in 2014. She's a researcher at SICA Packaging Department since 2015. She deals with European projects, several BioCopac Plus, AgriMax, and ECOFUNCO, focusing on the valorization of food processing wastes, in particular of tomato byproducts. She's also involved in the study and evaluation of the packaging materials in terms of shelf life and hygienic sanitary compliance. So the presentation today will go back to the AgriMax project, yes, and in particular talking about valorization of crop and food processing byproducts through an integrated cascade process. So Serena, the floor is yours.
Thank you very much, Alfonso, for presenting me, and thank you to the organizer to inviting also SICA to have the possibility to describe its activity during the AgriMax project. But first, just a quick look on what is SICA and which is its mission. So SICA is a research institute established in Parma in 1922 and with the aim of promoting technical and technological development in the agri-food sector and the food processing industry. This institute is composed of several departments strongly connected to the food sector. One of these departments is the packaging one, which focuses its activity on the hygienic sanitary control, as well on the correct functioning of the containers and of the materials involved in relation with their construction characteristic and operating condition for use. The packaging department is also involved in a research project related to the development of new sustainable packaging and also bio-based material intended for the food sector. These two topics are strongly related to the circular economy concept, which is also at the base of most of our project and the project presented today. We already know the issue of food waste and agricultural waste, which are of a very huge amount. Here are some data available from the statistics. So the need to reduce the impact of this waste is very strong. And this is because the researchers are trying solutions, and one of these solutions is reuse this waste, exploit this waste as potential sources of bioactive compounds. And for this reason, also born the AgriMax project, which is already illustrated by Beatrice, Patrizia, and also Cristina, the coordinator. So I will be very quick in this overview because we are late, and just some focus on the goals of the AgriMax project, which is was a very big consortium, and which cover the whole supply and value chain. And the main goal is, of course, the valorization of crops and food processing waste by extracting and using biocompounds and chemical and molecules available from these feedstocks to apply in sectors as food, packaging, and agriculture. For this purpose, two biorefineries were built, one in Spain and one in Italy. And through the flexible and integrated approach applied on this biorefinery, it was possible to valorize crops and food processing waste as from olives, potatoes, tomatoes, and cereals. This presentation is focused on the Italian biorefinery in which SICA was actively involved. This biorefinery was built in north of Italy, near Mantua, and the feedstocks processed are tomatoes and cereals. From tomatoes byproducts, the outputs were cutin, lycopene, and compost and hydrocompost, while for the cereal byproducts, ferulic acid and fibers were obtained and then used. Okay, so let's get more in detail in the SICA activities on the biorefinery. So concerning tomato waste, SICA focused on the peels and seeds coming from the food processing industries, so the processing of tomato products. With a protocol, SICA can extract cutin and lycopene through a cascade approach. The cutin will be applied in the biolacquer formulation for food metal packaging, while lycopene could be used as food ingredients, as a colorant. What is important is also that the residual biomasses generated during these processes could be also exploited by producing biogas. Okay, so what is cutin? Cutin is a component of the cuticle of tomato peels, and from a chemical point of view is a natural polymer of polyester type, which is mainly composed of 10,16-dihydroxyhexadecanoic acid. SICA applied a protocol for the extraction of this substance, which is illustrated in the flowchart, and it is composed of few simple steps, as a thermal treatment, a separation, and acidification. Some aspect important to remark is that this protocol avoids the organic solvents use, and also the equipment exploited for this extraction are commercially available also on the industrial level. So it is a scalable and industrialization, scalable process at industrial level. The further development of the project consisted in the formulation of a new biolacquer starting from the cutin as a building block. This process was performed also at pilot scale and using the same equipment used for the standard production of lacquer available on the market. So we don't need a different production process with different equipment. Thanks to this production, which creates a huge amount of lacquer, it was possible to apply this on metal sheets, and thanks to a company which applied this lacquer, we can produce the industrial company can apply on tin-free steel and tin plate sheets this lacquer, and then produce free pieces cans and open tops to perform the filling of the cans with specific food products in order to evaluate the behavior of and the performance of the biolacquer in direct contact with the food products. In order to have a big evaluation, we decided to select a wide range of food products with different characteristics. So tomatoes, tuna in oil, and legumes were the food selected for this evaluation. In this part of the project, SICA was mainly involved in the evaluation of the chemical and mechanical properties of the biolacquer, and also on the food contact compliance of this new packaging material, as well as the shelf life evaluation. The evaluation of the metal sheets coated with the new coating required a food content compliance, so overall and specific migration tests were carried out, referring on to the national and the European legislation. These tests are very important because they verify that the new packaging will not release hazardous substances and molecules for the human health, so it is safe for our consumption of the food products inside. Then, with the chemical and mechanical properties, we define the characteristics of the new lacquer, so which is the coating characterization and characteristic in order to preserve also the metal packaging from an attack coming from the food product in the inside. So the vacuum porosity is an electrochemical analysis where the sample is put in contact in a salty solution, and it is an indication of the protective property of the coating material. So based on Sika experience, a result lower than 10 milliampere on a square decimeter is a good protective lacquer. So we achieved this result, so we are very happy about this. So this lacquer is protective against damage coming from the food product to the metal packaging. Then the dry adhesion, which is a test that defines if the lacquer could be detached from the metal substrate. So it is an indication of the adhesion, in fact. This test is performed by stressing the surface lacquer by damaging it. So if no detach of the lacquer occurred, we passed the test, and also in this case we achieved good results. Then it is the thermal resistance, which is a test where the samples were put in contact with water and in presence of vapor, and treated thermally, in this case in a retort at 121 degrees for 1 hour. These conditions are specific, referring to the regulation, and are based on the future application we want to give to this packaging. So this will be treatment that will occur in the food industry. The verification of good results is performed by visual examination, a specific visual examination, and also by performing again the dry adhesion after this, also the stress of the thermal treatment. Last, the corrosion resistance, which of course define if the lacquer can protect the metal substrate from corrosion. That is an electrochemical impedance spectroscopy measurement. And here again, since we want to evaluate a wide range of products, we selected both aggressive and non-aggressive solution, which are citric solution for the aggressive one and cysteine solution for the less aggressive one. The results achieved give information about the lacquer that could be suitable for low-medium acidic food products, which more or less are constituted of tomato, tuna, and legumes as the food selected for the shelf life evaluation. Here, very quick, some data about production. So here are numbers. So starting from the biorefinery, at the end of the project, we could process 500 kilograms per hour of tomato byproducts. Some trials were needed to optimize the cutin extraction, and after the optimization, 90 kilograms of cutin were produced for the industrial production of the biolacquer. With this cutin, 90 kilograms of biolacquer were produced and applied on industrial line on metal substrates. With this, it it was possible to produce 6,000 tinplate cans of half-kilo size and 500 tinplate cans of 80-gram size. And then some part of these cans were used for the filling process for the shelf life evaluation with different food products. Now, let's move to the second product recovered from tomato peels, which is lycopene, and a molecule present in red fruits and vegetables, of which tomatoes is one of the major contributors. It is known as a natural antioxidant and also a colorant in food application. From the chemical point of view, is a carotenoid, which structure is present in the photo. Okay. Concerning the extraction of lycopene, Sika extracted this molecule from the tomato peels discarded from the cutin extraction process. So we have an additional valorization of these byproducts. First, Sika developed the extraction protocol at laboratory scale using a 2 liters capacity Naviglio extractor. Then it was possible to scale up this protocol at a larger scale on the biorefinery, which uses a 4 liters Naviglio extractor. We obtain lycopene in the form of an oleoresin, and that could be applied as a food colorant. Of course, this research needs still be optimized. We didn't achieve a complete satisfactory result, but we are happy to have improved the extraction process in terms of byproducts processed. Since we are talking about biorefinery and multi-feedstock treatment, we have to mention also the other feedstock treated on the Italian biorefinery. Here are tomato, cal fruit, and plant. And from this, compost and hydrocompost were obtained for the agricultural sector application. And last, cereals, specifically wheat bran, as already mentioned, find their application mainly in the food packaging and in the packaging sectors by using as biopolymers and extracting ferulic acid and using the fibers, the residual fibers. Here in these slides, some photos of some of the demonstrators as packaging materials. So to go to conclusions, well, all the feedstock treated and tested on the biorefinery was successfully extracted, and all the products obtained were applied in their specific sector. Concerning the cutin, we are happy to extract a large amount of this substance and have the possibility to formulate and apply on industrial line the biolacquer formulated. The migration test verified the compliance to food contact, so it is a safe lacquer. And the other characterization analysis defined that this lacquer is suitable for packing medium and low acidic food products, as for example tomato, legumes, and tuna in oil. Concerning lycopene, the identification of the extraction protocol was successful at laboratory scale. We scaled up the protocol, but further research is needed as optimization of the entire protocol of extraction. So last, since cutin is found to be a promising raw material for food packaging, I want to thank the whole ECOFUNCO consortium to have the possibility to improve the applications of the cutin. In fact, in this project, new materials were studied as cellulosic and bioplastic substrate as a new possible substrate for cutin applications. So I want to thank to all the consortium for this opportunity. And thank you to all for your attention.
Okay, Okay, thank you, Serena, for this interesting presentation, highlighting the importance and the possibilities of cutin in particular for this application. We are just studying it in the ECOFUNCO project, so we go on.
Yes.
The floor is open for questions. Please. Chris.
Chris.
Okay. Thank you for your interesting presentation. I have just a question. You said that the no-organic solvents are used to extract the cutin from the tomato byproducts. So, what kind of process and which chemicals or solvents did you use? If it's possible to know, of course.
Yes. I think it's known in the literature. There's no secrets. We use alkaline treatment.
Just alkaline.
Yes. Okay. In the literature is known that there are many processes starting from tomato peels that can eliminate some other part, impurity and so on, using organic solvents. So we found that we can skip all these solvent protocols and use an alkaline treatment to recover the cutin from tomato peels.
Okay, thank you very much.
Other questions? Please.
Thank you a lot, Serena, for the presentation. It's Sergio Guisada from ENCO. I was wondering, well, maybe it's a stupid question, but regarding biofibers-based materials, you have the means, the machinery, the capacity of extracting the biofibers from raw materials such as hemp, of kenaf, or that kind of plants, process them and obtain the biofibers ready to manufacture composites based on biofibers for application for like automotive of building or that kind of demonstrators?
It's not a stupid question. Well, the AgriMax consortium and project have the goal of creating a biorefinery that could process every kind of feedstocks, if possible. We focused only on tomatoes, cereals, and on the Spanish part, olives and potatoes. But potentially, if the equipments are suitable for the extraction of other feedstock, why not? But yes, you need to have a protocol, a sort of protocol, and then evaluate, I think, the feasibility also, but it could be worth it.
You think you will need a high investment, a high capex to adapt the processes for fiber materials?
No.
Okay, thank you.
Okay, thank you. And thank you again, Serena, for this very interesting talk.
Thank you.